Good morning, everyone. Thanks, Mariola. Just wait for the slides. I suppose today is about Part C of the building regulations, but Part C doesn't work unless you use Part D, proper materials and workmanship to ensure, and the assessment of the materials is an important part of compliance with Part C. And Part D is paramount really to all of the building regulations. You know, if you don't use the proper materials, the workmanship, you're going to lead to failures within other aspects of the requirements So these are the requirements. C1, the legal requirements that must be met is this C1, preparation of the site. The ground to be covered by a building should be reasonably free from vegetation matter. C2 is subsoil drainage. Subsoil drainage should be provided if necessary to prevent the passage of ground moisture to the interior of the building or damage to the fabric of the building. C3 deals with dangerous substance. Reasonable caution should be taken to avoid danger to health and safety caused by substance, including contaminants. And then C4 is resistance to weather and ground moisture. That's the floors, walls of a building shall be designed and constructed as to prevent the passage of moisture to the inside of the building or damage to the fabric of the building. And then there's a definition of contaminant and floor given and moisture. So site preparation, so it's basically the turf and other vegetation matter that should be removed from the ground where you're going to place your building on. And you'll see that there where you have tree roots, vegetation, grass, and then you're trying to put a floor on top of that, and you need to make sure that that's proper sound. So it goes back to Part A, loading as well. So it's important that, you know, like ground conditions and sites and all that, in the last couple of years, we've gone to maybe less desirable sites because of land use and all that. And they need a lot more work to bring them into compliance, to bring them up to Part A for loading. You have water table issues, that needs to be addressed. And like you can see, these are photographs that's taken on site visits, and you can see the depth of the foundations is increasing, the vegetation. So someone has to, they might use it as temporary, but then you have to make sure that all that vegetation is dug out and taken off site and the foundations, and making sure that that water is out of the foundation before you pour it, because there is enough water in concrete, as Tom will, from Roadstone will talk in his presentation, that this is, you don't need to add in any more water on the site when you've designed the mix. Subsoil drainage, and this is really because of years ago there was land drains put into existing fields and wee shores or things like that, stone drains and they need to be diverted, and that water needs to be collected and diverted into a proper water course when you're actually developing a site. And they're very practical, you know. You don't need more water around your development. It's only going to cause damage to the foundations, to the structure, that. Dangerous substance, and this is really the contaminants and all these radioactive material, and radon has been addressed in this section. And most people come across as the radon thing, but it all deals with contaminated land as well, which is probably going to become more in the future, and probably we'll do a short webinar based on that. But radon is a naturally occurring radioactive gas. It enters buildings from the underlying soil, and in certain cases accumulates within the building in a concentration, and it can be deemed potentially hazardous and life-threatening. And the number of people that die with related radon thing in the year is maybe 300-400 people a year. So every dwelling has to have a limit of 200 becquerels per cubic metre, and the radon protection Act in 1991 and the ionisation on the regulation SI 30 of 2019 really was the implementation change for Part C to 2023 because it's a regulation, and it relates back to existing buildings where the buildings other than dwellings where the becquerels was reduced from 400 to 300. So it's part of the Health and Safety Work Act. So if you're part of your local authority building, you'll have to retest the building to check that you're below the 300. If an office building or schools, they all come in under this, they all have to be retested. It also deals with the new radon maps, the interactive map, the red colour areas. So if you're in a board of management or on a school board or children going to any of these schools in these red areas, I'd recommend that you advise the board that they should actually get a radon test done on the existing building. And it doesn't cost that much. It's about €50 to get the radon thing. It stays in the building for about 3 to 4 months, and then they get and then you have that definitive result that you know whether you have a high or low radon area, and you can then go on to address it under the building regulations. So materials and workmanship, fit for purpose, and this is the proper materials. We hear the word proper materials. What is proper materials? You know, and it's really proper for its end use, durable in the conditions that you're going to put it in the climate that we're going to have. Ireland is very kind of unique climate. We get from -10 to about 30, 35 degrees. So that's a 45-degree swing in temperature. Most materials, you know, perform differently under different conditions. Like PVC is affected by UV light. So like our internal plasterboards, you can't do that on outside because they're organic and they absorb moisture, and then when they get wet, they expand. So it's understanding the limitations and the use of the materials and how you can actually design them and design them into the building in a way that they can be used, but also how you address that maintenance to the end user going forward. You know? These are not gold bars. They're not going to stay. Like, if we could build our houses out of gold bars, we'd know that they'd be very durable and they'd last. But it's not practical, you know? So the materials proper use. So they bear a CE marking in accordance with the provisions of the construction product regulations. So manufacturers, DOP and CE marking. Comply with an appropriate harmonised standard or European technical assessment in accordance with the provision of the construction product regulations, and comply with an appropriate Irish standard, Irish Agreement Cert, or alternative national technical specification of any state which is contracting part to the agreement of the European Union area. And the Agreement Cert process has come on a lot in the last couple of years. A lot of materials there, and this is the explanation note on the guidance on the thing, and it says the process of Agreement Certs applies to those products and processes which do not fall within the scope of existing construction standards, either because they're innovation or because they deviate from established norms. The NSSI Agreement process specifies testing where appropriate, and they issue an Agreement Cert, and they're always assessed for Irish building regulations and Irish standards. And we have our Irish standards, and there's national annexes attached to our Eurocode designs and stuff like that that need to be considered when you're actually assessing or getting your Agreement Cert. And most BBA certs are only assessed for UK regulations, so they're not comparable because of the national annexes we have here are slightly different. So there may be a lot of other design considerations. And you may have to go back and review everything as a designer to actually be able to demonstrate compliance with the product and the use of that product. So the Agreement Cert, and There is a search facility on the argument cert on the NSSI website. You can put in the manufacturer's name, the product name, or the product area, and just because today is radon protection, we just selected the radon. You can see a list of radon products that have argument certs. The CE marking is not applicable to radon membranes because it's not a harmonised standard, but the membrane part of it can be DOP CE marking because it is a harmonised standard. Delivery and storage and marking. So rolls are supplied individually on pallets in wraps, and so this is how the traceability is there. And the other thing, installation. Now, all these argument certs have little contracts. You have to do this, I do that. They're kind of like information, but they're also spelling out your responsibilities, their responsibilities. But here, this certificate does not contain a full set of installation instructions, but an overview of the procedures involved, because it's only 11 pages, so it can't really provide every information that's there. So it tells the certificate holder they have a manual. So many people has actually requested the manual as part of the argument cert, even for the installation of radon membrane. Many contractors that's installing the product has actually requested that, So these are things that's part of your responsibility as a designer and a contractor or a builder, to actually make sure that you're informed and have the information to carry out that. The radon sump. So you can see here, consider that couple of blocks stacked on top of each other. Would you consider that suitable? Materials fit for purpose? No. The DOP for a block doesn't say it can be used for that. And this is really where people need to go back and actually check. There is a product here that has been assessed by argument cert that's fit for purpose, fit for use, for its intended use to collect the radon gas and provide an outlet. And these are simple, don't have to invent the wheel, you just have to know where the product is, Hardcore layers should be clean, dry, gas permeable, compacted. The 1 sump per 250 square meters or 15 meters. But in practical terms for individual houses and semi-detached houses and that, it's usually 1 per house, Some people try and get away, but then who's responsible then if there's an issue and there's a high level radon and when it's tested, and the person doesn't have access to the outlet sump here. Also the products and identification on the marker outside. And if you're in the red areas, I would recommend that you actually extend the pipe up and to carry out your testing, because at least you know that you're in a high radon area. You can, and remember that building regulations are minimum requirements. There is nothing stopping you going above that requirement. This was the radon in existing buildings document. It's nearly 20, 30 years old, but it identifies the paths that radon could get into houses, at junctions here and walls. And even when you're actually designing your location of your outlet pipes, like, not practical to have it in front of the door, not practical to have it in the middle of the footpath, Like, these are real life, these are things that people are not taking consideration, Consider where your plan is and your thing, because if you have to install one of these at a later date, you don't want it going through the middle of a window, you don't want to put excess junctions or bends on it, And I suppose we move on then to how market surveillance and building control coexist. and interact with each other. So you have the construction materials here, the harmonised standards, a system of verification, the DOP CE markings, and then you come in here to your building on site and your standard recommendations, and they may be part of the DOP as you find out for the blocks and that. Materials, workmanship, fit for purpose, compliance with the building regulations, and proper installation is all covered there. And how does this kind of affect us? Because the aggregate for on-the-floor fill is covered under EN 13242, which is a harmonised standard. Our national provisions are SR21, which are unique to Ireland, out of the 20 other 7 states that are part of the EU. And we have specific requirements here. When you actually get your DOP, you need to check what you're actually buying here. So this is a T3 blind. You need T1 or T2 or T0 strut. And you need to make sure that that's specified. The CE marking, check here the code here, that's the notified body. You want to check that it's a System 2 Plus as well. And the hardcore should be placed. So this is where the building regulations and the construction product regulations overlap. Building regulations tell us that you have to install that product in this format, in these layers. It doesn't say that you have to use SR21. It's telling you that you have to use SR21 in these layers. So T0 strut is 0 to 125 mil for depths greater than 900 mil. Now, that is an implication for part A structure, so there's testing required to make sure that that loading is achieved. T1 strut on brown granule fill, material in, and it's graded from 0 to 32 or gravel 0 to 40 to facilitate compaction. The T2 perm, which is part of getting your radon sump and your gas, and that layer is 200 mil of 4 to 40, so there's no fines less than 4 mil in that thing. And then the fine aggregate there is 0 to 4, and that's a bedding material on the top. And these are the layers here. But that's one product, and it's how you bring that product into complying with the building regulations. And that's the fit for purpose, fit for use there. You must provide the product in that layers. So generally you'd have a concrete floor slab, you'd have the insulation, you'd have the rain retardant membrane or the DPM, the T3 blind, T2 permeable gas 200 mil, T1 strut or T0 strut, depending on the depth of the fill required. Where the blind layer is used, it should be provided in accordance with the specification in Annex E. For the fines materials, the blind layer should be adequate depth to fill the surface voids, thus creating an even and avoid sharp projections, because you're putting a very thin layer of plastic membrane down. So you don't want it punctured, because people have to walk on it then to put the insulation on it. No one's going to be wearing, not allowed to wear slippers on a site to do this work. They're all going to be safety boots, stuff like that. So there's other legislation that you have to take into consideration that they have to carry out the work with that. But you can actually see here, one of the houses that was remediated under the pirate scheme, that's what they found in one of the houses. So, fit for purpose, fit for use. And it's the care and detail around the ceiling and jointing that need to be part of it. So whether it's a radon membrane or a DPM, you need to tape the joints. You can see the workmanship and the joints, lovely square details, lovely and flat for the blockwork to go on top of it. Very well done. I'm sure there's other bad examples out there, but it's all about getting that detail right and that workmanship and the sealing of the pipes and penetrations and all that. And as we go through the day, you're going to hear more on from Pat on that. So the radon it significantly reduces the overall radon concentration. However, there's no guarantee low radon levels in the finished dwelling. Just because you put down the radon barrier does not mean that it's a precautionary measure in the building regulations to get you to that, but it will not deal with high radon, and you may have to do additional measures after you test. So after Part C of the building regulations, so the sign certifier can't sign off on, he signed off on the work that he did, but he can't sign off on the radon levels because that needs to be tested post-occupation of the dwelling house. The other thing that's a useful document is the limiting thermal bridgings and air infiltrations. And if you follow the ACDs and detail out, there's a lot of junctions and how the membranes and all that contribute to the air tightness of the building if they're properly installed as well. And they're all there. They're prima facie compliance. And the other thing with the more airtight you make the building, the less radon gas can get out. So there is going to be, if you're doing retrofitting on houses and stuff like that, you need to consider radon as part of your strategy. If you're lifting up your floors, maybe you put down in your membrane that. Move on to C4, resistance to the weather, moisture. The floors, walls, roofs of a building should be designed and constructed as to prevent the passage of moisture to the inside of the building and damage to the fabric, floors. And moisture includes water, vapour and liquid water. And we have this issue of failure of blocks and around the country, cracking, weather, render. And this is because we're allowing moisture in. Chemical reactions don't need a catalyst to happen. So we need to, and all products will react to either heat, moisture, cold. Damp-proof courses, and this is all about rising walls. So how do I stop that moisture? Because these are porous elements, and you need to make sure that you're not adding to moisture. So this is not covered in the thing, but this is a solution to get round drainage. Planting areas, becoming a big feature around the country of architects and stuff like that. But has someone designed the DPC in there to make sure that that membrane, that soil and that's not going to damage the fabric of the building? You know? Rain cladding, external walls resist the penetration of rain or snow to the inside of the building, not to be damaged by rain or snow, and to carry the snow around, which would be damaged by it. So cladding joints, and cladding is becoming more and more popular in the last 10 years, even on dwelling houses, stuff like that. And it's the cladding, what is it made of? Like if it's metal, it's going to be preventing it, moisture coming in. But the issue then is you might have a Part L consideration, you might have interstitial condensation in the wall. So it's not, you can't look at one part of the building regulations and say I've complied with it. You need to look at all parts. So there can't be any greater contravention between any parts of the building regulations when you're carrying out work. You can see here, the block work here, and they're just putting on the cladding here. But if you go to the DOP for the block and how that is rendered, that wall would have to be rendered before they could actually put on that. Depending on the exposure location of that, it will need a render before that's fixed to it. Because that's a natural stone, it's permeable. Do you know? It'll absorb water. And if it's absorbed water, it will absorb water. And then you've moisture movement through the building. You know, I came across this one here, I thought it was really good. Intello membrane, used to prevent as a barrier for ICF. on a house. Really, I don't think Intello membrane is to be used outside the building envelope. But this was they were building stone facing onto ICF. They didn't render the ICF, so they didn't comply with the agreement cert process. Now, they're depending on this membrane here, which is not designed for that purpose, not fit for that purpose, to act as a barrier. Remember, Part C of the building regulations is prima facie compliance, so the wall types that was given in it was a masonry cavity at least 50 mil wide, so to provide and to allow drying out. You know, an insulated material may be placed in the cavity between an outer leaf and an inner leaf of construction, and where the cavity is to be filled, only the insulated material which has been shown to satisfactorily prevent the passage of moisture to the inner leaf may be used. And that's all in Part C of the building regulations. Now, that's in since 2005, it hasn't changed. It's currently looking at different, Simon is involved in the updating of Part C, but in the next year or two, we're going to see a new Part C, hopefully.
What about cavity full fit insulation? Full fit insulation?
That's the same thing. It doesn't, if the cavity is to be filled, it doesn't say what it is filled with. So if it's full insulation, you need to make sure that that insulation and the agreement cert and the assessment and the exposure thing is being actually considered. And that depends on your wall type, or whether you're using block, brick, and then you need to actually go to the previous SO325. So it's not as simple as accepting one piece of information. You need to go and look to see, am I complying with the other requirements of the building regulations? And this is why it becomes very technical. And Part C is probably very technical when you actually go into the exposure classes. So the recommendations of masonry, expansion joints, blocks, and the location of the expansion joints. The performance of the masonry and the guidance on marking and block give a sample DOP. And if you go in here on the dimensions, you'll go down through here where it actually tables and the reference in the tables. And the durability is down here and how that's met of the product. So blocks are not durable. People assumed that concrete was durable for years. Concrete blocks are not durable. SO325, if you read it, will tell you that they're not durable. They need to be protected. They need certain protection. And durability against freeze thaw and the density that you need to have. And this all refers you back to the mortar strength and everything like that. So it's becoming very technical, where you need the engineer, the structural engineer, to understand Part C and how that interacts with Part A of the building regulations and Part D. And maybe Part B and L are the other ones that are required. So the construction product regulations and the provisions, external renders are found there in Annex C and F, insulations, and the construction, acceptable construction details are there, the wall ties, aggregates for the blocks, the damp-proof caution, and all that detail and all that. And you'll find that the Part C implements a lot of this stuff requirements. We all think the blocks are Part A, the structure, but it's as much to do with Part C of the building regulations, even more important than Part A, you know. The other thing was the slating and tiling code of practice. SR 82 2017 gives guidelines for the materials, design and specification recommendation and workmanship required for slates, tiles and their associated fittings and accessories used in the construction of pitch roofs and vertical cladding applications of ridge heights not exceeding 10 stories above the joining ground. And it's proper detailing And with the drone technology now, you know, some of the local authorities have the access to drones, so we can actually fly in and pick up these details and check to see that the batting is SR3. We don't even have to go up on the roofs now. Great. That the valleys, the laps and all that are correct. We all forget that we live on an island sometimes. But our island is very unique. We have the Atlantic Ocean from here to Waterford. We have the Celtic Sea to up near Wicklow, the Irish Sea to here, and the North Sea here. So you're surrounded by 3 seas and an ocean. This side of the country, more exposed than this side, but the exposure map doesn't take in specific areas, and it's kind of limited, and it tells you, look at the height of your building. If this is designed on a 10 metre, anything over 10 metres is not really considered by this map. So you need to be in a higher exposure class. You know, so the structural stability, weather tightness, ventilation, shape of the roof, the durability, control of condensation, thermal performance, hydrothermal factors, and health and safety considerations, fire, sound, and resistance. These maps are going to be updated as part of SR325. They'll be updated as part of the standard SR82. You know, so the assessment of exposures and wind-driven rain, you know, moderate exposure, 5 square metres, and then anything over severe exposure is anything greater than 5 square metres. And Donegal is up on 15. Kerry down here is about 10. The only place that's really low enough is Dublin, around a 5. So a house built in Dublin, same house built in Donegal or Kerry would have to take greater considerations on moisture getting into the building, on the thing, wind speed and all that, materials fitting on the underlay and the roofing. You know, the laps is usually 2 holes in a tile, but you only have to nail one of them, and that's so if you want to split them. But generally, a couple of years ago, it was every 3rd row that had to be nailed. Now it's every 2nd in moderate areas. If you go into severe, you're nailing every slate and you're clipping in as well. And Aidan will go through that later. And the underlays all have to be fit for the use. They have to be in the area, and then I have to allow a little bit for movement and the laps that you're actually providing. So the lap here on the material has to be the minimum here, and that depends on the pitch of the roof, and also depends on the exposure and the wind exposure and the lift that you're providing. The other thing to be aware of is glass fibre valleys. There's a lot of new valleys coming onto the system. You need to see the durability of them, the lifespan of them, to consider them. And is it an easy replaceable element? Like if you're only doing a wee small roof like that, probably yes. But if you're doing a larger valley, as shown on the first one, that's a major work to replace that. If it has to be replaced after 5, 6 years, 10 years. You know, like you want your roof to last 50 to 60 years. And that's with maintenance too. People think that the design of the building is 50 to 60, but you have to carry out maintenance to achieve that. The competent person and the design in the code of practice, you know, this is part of the compliance as well, inspect and design. The inspection notification framework, you know, the different layers of the fill, the sump box. That's all part of your inspection plan. And that's really getting into your builder to get you to notify, so you can actually go out and actually verify that and check all them details on site. Just remember what you're designing. You designed in conjunction with others, and you certify the such design that you're one of the registered professionals, and having prepared and exercised reasonable skill, care and diligence by me and others, members of the team and specialist designers who have design activities I coordinate and have prepared and demonstrate compliance with the requirements of the second schedule of building, insofar as they comply to the building works. So you're signing off that the design is right. So, thanks.